All right, so clearly Miss Green is not good at cleaning anything. Sorry, it's a little smudgy still. I want to do number 3 from our mass to mass stoichiometry problem homework, okay? So you may or may not have noticed that Ms. Green has lost it and has a word part of the problem that does not even come close to matching the balanced equation that she gave you, okay? So for instance, the balanced equation, okay, that she gives you is magnesium plus 2 moles of our sodium fluoride yields, okay, products of magnesium fluoride plus 2 moles of sodium, okay? However, if you read the words that are underneath this equation, it says if you start with 5.5 grams of lithium chloride, is this lithium? Is there a chloride in here? How many grams of calcium chloride will be produced? There's no calcium, there's no chloride, there is nothing of the sort. No lithium. So please disregard that. We are going to do the same problem with the same values, but we're just going to change the compounds that we're looking at to actually match the equation that we're focusing on, okay? And so what I'm going to say is our starting amount is still the 5.5, but instead of lithium chloride, because the heck, we are going to say 5.5 grams of our sodium fluoride, Look at her, she cute, okay? And instead of our destination being our calcium chloride, because again, the heck, how does that work? We are going to go ahead and see how many grams of our magnesium fluoride we got, okay? And so, again, we are not magicians. Out of this balanced equation, we cannot magically produce calcium, lithium, or chlorine. If only. You know Miss Green would totally make gold if she could. All right, alchemy at its finest. So, we have our starting point, we have our ending point. Now, just like the previous problem, we gotta fill in the business right in here, okay? So how my brain works is I realize I need to transform this grams into something that's usable, right? To get me to this intermediate molar ratio step, which is like literally a stepping stone into getting to finding how much of another substance in this reaction we have, okay? So the first part that we're gonna do is we're gonna look specifically at the molar mass for sodium fluoride, okay? So I'm gonna go to my handy dandy periodic table, and she tells me that sodium is 22.99 grams per mole, and then fluorine, that's French for fluorine, will be rounded to 19, okay? So got my handy dandy calculator, and I will plug that on in. So we have 22.99 plus our 19. Beautiful, 41.99. Okay, so 41.99 grams of sodium fluoride per 1 mole of sodium fluoride, okay? So now what I'll do is I'll plug in this conversion factor right next to this guy, okay, in order to configure and figure out how to transform this into moles. So you can think back to our little molar map, the divide, multiply, right? And if you recall that, we will divide by the molar mass. If you don't remember your mole map and you want to try and do this problem on the fly, you can do the Miss Green method, in which you're trying to configure this helpful chemistry tool out of our chemistry toolbox, right, in such a manner that we are getting rid of the grams of sodium fluoride, because that ain't it, chief. We want to get rid of it, okay? And how we do that is by putting our grammage into the denominator. So we have 41.99 grams of sodium fluoride for every 1 mole of sodium fluoride. And so again, please label what moles or grams of what substance you're talking about, because things can get real hairy real quick, okay? So after we have that, we are going to cancel out our grams of sodium fluoride, okay? So that's done. That's done. We're left with moles of sodium fluoride. And if you recall, we're trying to get to grams of magnesium fluoride. So we still got a little ways to go. So now that I have this transformed into moles, I am now at that sort of stepping stone step, if you will, to try and now relate something about our sodium fluoride to something about our magnesium fluoride. And how we do that is going to be our balanced equation, okay? So now I need to try and relate the molage, that's totally a technical term, of sodium fluoride to the molage of the magnesium fluoride. And so how I do that is I look right out front. So here's my sodium fluoride, here's my magnesium fluoride, and I'm comparing these coefficients, okay? So I have 2 moles, okay, because that 2 is, hang on, it's like not focusing, there we go. 2 moles of our sodium fluoride, okay, for every 1 mole of my magnesium fluoride, right? Because if there's not a number there, it's an implied 1. So we have our 1 mole of magnesium fluoride, okay? So now we need to arrange this in such a way that we are now canceling out our moles of sodium fluoride, because that is nowhere part of our final solution, okay? Solution, do you get it? Like a solution with substances in it and chemicals, solvents, yeah. I'm funny, okay? So the way we'll do this is we'll put our molage for our sodium fluoride into the denominator. So we have 2 moles of sodium fluoride, okay? That goes in the bottom. So to complete our molar ratio, we have to put in now our 1 mole of our magnesium fluoride. Okay, so what's going to happen is we're going to cancel out our molages of sodium fluoride. It's going to happen, okay? I know you're probably screaming at home. It's never going to happen, Miss Green. Just like fetch never happened for Gretchen, molage is never going to happen for chemistry, but a girl can dream. So what we're going to do now is relate our magnesium fluoride, okay, which is part of what we want, right, but 2 grams of magnesium fluoride, okay, because this is not where we're at yet, right? We're basically talking about particles or atoms when we're talking about moles, and we're trying to find the actual mass of one of our products, okay? So how we do that is now bringing in our molar mass of magnesium fluoride, okay? So let me bring this up just a little bit. So I go back to my handy dandy periodic table, love her, okay? Iconic, if you will. And magnesium has a mass of 24.31, plus keep in mind some of y'all kind of tripped up with the subscripts and what that means and finding molar mass with the subscripts, okay? We have 2 fluorines, okay? And fluorine has a mass of 19.00, okay? So once we add this together, we get a total molar mass for magnesium fluoride to be, let me get my little calculator. She's cute, okay? So 24.31 plus 2 times 19, bam, is 62.31. So 62.31. This is grams per mole. So if I have 62.31 grams per mole, 1 mole of magnesium fluoride, okay, And I'm trying to see how is this conversion factor going to plug into my running chain to get me to my final sort of desired answer. I'm going to look and I see I want to get rid of my moles of magnesium fluoride. So perfect. I can insert the molar mass as is. I'm going to take this chunk and I'm going to throw it up. Not literally, that sounded really disgusting. I'm sorry. I am so sorry. Mistakes were made. Ew. Miss Green will not be throwing up on this phone video. All right, moving on. So grams of my magnesium fluoride over my 1 mole of magnesium fluoride. And I know, it's getting tight. It's getting a little crazy. I try to be ambitious and do everything in one line, opposed to the last problem. And look at where it got us. But that's okay. That's okay. So now our... oh no, my marker fell. Our moleages... Y'all, quarantine is really making me go absolutely nuts. Our moleages of magnesium fluoride is now going to cancel, okay? Because we have 1 on top, 1 on bottom. One thing divided by itself is 1. So effectively, it don't exist no more, okay? So what we're left with in terms of unit is grams of magnesium fluoride. Okay, and that, if you recall from the beginning of this millennia-long video, that was exactly where we were trying to be. So now, if this looked normal, we would have the ability to make our little equal sign and we can start calculating, okay? Again, just like dimensional analysis of chemistry past, I have not even touched my calculator until I have this set up. I know you're going to be very tempted, okay, to just start putting things into your calculator automatically because you're like, oh, I get it. Oh, I understand. But it is very easy to kind of mistype, miscalculate, maybe not have the right orientation of your conversion factors. So I highly recommend, even though this seems like a lot and extra as heck, that's Miss Green for you. I promise you, the more you do this, the more second nature it is, and the faster you can sort of pump these out, and the easier you can see what your calculation mistakes are, right? Because if you have it set up like this, you can say, oh, I multiplied by 41.99 instead of divide the way it should be, because I know this exact order of operations and values where they're at is correct because my units match up with my desired outcome, okay? So now I'm gonna put my let me show you what I'm doing. So I have my 5.5, okay? Times my 1, big brain time, I'm not going to do that. Times my 1, big brain time, not going to do that. Times my 62.31. Times 62.31. Enter. Okay? I have my 342.705, but we ain't done yet. We ain't done that. Now we need to do our bottoms. So what we do is we now divide by everything on the bottom. I'm not going to divide by the implied 1. I will divide by 41.99, and then I'm gonna press enter, okay? Because if you try and do divide, you might end up with something funky, and we do not want that, right? So then after you have that first one, now we move over, we divide by 2, say enter, okay? Moving along. Divide by 1, enter. But big brain time, that's going to be the same exact number we already have in our last entry, so we're going to ignore that. Okay, and oh, that's it. Very exciting. So our final answer, okay, is going to be 4.08 grams of magnesium. Oh no, this needs to be in blue. Yeah, there we go. Of magnesium fluoride. So that is how you do that problem. Hopefully this was helpful. Some Catch y'all later.